Moving on to fifth problem. In figure 6.17, POQ is a line, ray OR is perpendicular to line PQ. OS is another ray lying between rays OP and OR. Prove that angle ROS is equal to half times angle QOS minus angle POS. Now, moving to the solution. If we observe the figure, we can say that POQ is a straight line which is intersected by RO ray. Then angle POR and angle QOR form a linear pair. Therefore, sum of angles, that is POR and angle QOR, is equal to 180 degrees. That implies angle POR plus angle QOR is 90 degrees since OR is perpendicular to POQ. 90 degrees is equal to 180 degrees. That implies angle POR is equal to 90 degrees. If we observe the figure clearly, we can say that POR consists of two angles, that is angle ROS and angle POS. That implies angle ROS plus angle POS is equal to 90 degrees. Let us name it as equation 1. Again, if we consider POQ is a straight line intersected by SO ray, then angle POS and angle QOS form a linear pair again. Therefore, sum of angles that forming a linear pair is equal to 180 degrees. We can write angle POS plus angle QOS is equal to 180 degrees. Let us name it as equation number 2. Now, in order to make the equation in terms of ROS, QOS and POS, we need to multiply equation 1 with 2 and have to subtract it with 2. Equation number 2. That implies 2 times angle ROS plus 2 times angle POS is equal to 180 degrees. That is equation number 1. And minus equation 2 is angle POS plus angle QOS is equal to 180 degrees. Now on subtraction, it is minus, and this is also minus, and this is also minus. Now we get the equation as 2ROS will be remain as it is, and 2 angle POS minus POS is angle POS, and we are left out with minus QOS. And on right hand side, 180 minus 180 will be 0. That is, we can write it as 2 times angle ROS plus angle POS minus angle QOS is equal to 0. That implies 2 times angle ROS is equal to, on transposing angle POS and angle QOS to right hand side, we get plus angle QOS minus angle POS. That implies, again on transposing 2 to right hand side, we get angle ROS is equal to half times angle QOS and minus angle POS, which is a required proof. Now moving on to the sixth question, it is given that angle XYZ is equal to 64 degrees and XY is produced to point P. Draw the figure from the given information. If ray YQ bisects angle ZYP, find angle XYQ and reflects angle QYP. Now moving on to the solution. Here he has given that angle XYZ is equal to 64 degrees. And xy is produced to point P. Let us extend xy, that is to point P. Draw the figure from the given information. We have drawn the figure. If ray YQ bisects angle ZYP, that is ZYP is bisected by Q, this we can say that angle ZYQ is equal to angle PYQ. Find angle XYQ and reflex angle QYP. Let us assume that in the first case, angle PYX is a straight line and it is intersected by YQ. Then we can say that angle PYZ and angle XYZ form a linear pair. That is, the sum of two angles that forming a linear pair is equal to 180 degrees. Therefore, we can write that angle PYZ plus angle XYZ is equal to 180 degrees. That implies angle PYZ plus angle XYZ is 64 degrees, which is equal to 180 degrees. That implies angle PYZ is equal to 180 degrees minus 64 degrees, which is equal to 116 degrees. We know that YQ is bisecting angle PYZ. We can say that angle PYQ is equal to angle QYZ, which is equal to half times angle PYZ, that is equal to 116 degrees by 2, which is equal to 58 degrees. Here we got the value of PYQ, that is equal to 58 degrees. We can say that angle PYQ and angle QYP are same. Therefore, angle QYP is equal to 58 degrees. Later, he asked us to find angle that is reflex of angle QYP. Therefore, the reflex angle of angle QYP will be equal to 360 degrees minus 58 degrees, that is equal to 302 degrees. He asked us to find angle XYQ also. Therefore, in order to find angle XYQ, we need to add angle XYZ and angle ZYQ. That is, angle XYQ is equal to angle XYZ plus angle ZYQ, that is equal to angle XYZ is 64 degrees and angle ZYQ is 58 degrees, that is equal to 64 degrees plus 58 degrees is 122 degrees. That is the required answer.